Everyone, I am Anmol from Government Engineering College Vaishali. Today I am going to demonstrate the simulation of washing machine using PICSIMLAB that I learned during my internship of Embedded System under the Emertxe Information Technologies. The things that I learned in internship: Introduction to Embedded System, Basics of Embedded C, Introduction to Microcontroller and Microprocessor, Introduction and Project Requirement, into implementation using MPLAB, XIDE and PICSIMLAB. Embedded System: Combination of hardware and software, programming using Embedded C, example washing machine, microwave oven, AC, refrigerator, etc. Types of embedded system: on the basis of performance function requirements, real-time, networked, mobile, standalone. On the basis of performance of microcontroller, small scale, medium scale, and etc. Basics of Embedded C. Uses of Embedded C. Embedded C used in the system software, embedded software, operating system kernel development, and more. Characteristics of Embedded C: general purpose language and has library facilities. Code format: documentation, preprocessor language, and has library facilities. Data type and number system: integral and floating point, decimal, octal, and hexadecimal binary. Conditional constructions: looping, for, while, or do while. Block of embedded system: sensor, analog to digital converter, processor and ASIC, digital to analog converter, and actuators. Microcontroller: IC capable of being programmed to perform a task, has simple design architecture, all components are available in simple single chip. Microprocessor: IC capable to being programmed to perform any task, comparatively complex design architecture, peripherals needs to be interfaced. IPC16F877A board: the operating frequency of board is 20 MHz. The flash program memory is size 368 bytes. EPROM data memory is of size 256 bytes. There are 15 inputs in the board. The input-output port are 5A, B, C, D, E. 3 timers, 2 PWM modules. It also has various components like CLCD, fan, Tactile Switches, buzzers, LEs, ADC, RS232, etc. Project requirements: goal: simulating a washing machine using PICSIMLAB, replicating a real-world washing machine. Microcontroller used: IC16F877A. Software used: MPLAB, XIDE, PICSIMLAB, XC8 compiler. Project requirements: MPLAB, XIDE. MPLAB is proper freeware IDE. It is developed by Microchip Technologies. It is being used for programming and development purpose for embedded system. The version which we have used our project is V5.35. Project requirements: PICSIMLAB. PICSIMLAB is a properly free software for simulation of various microcontroller board available. It can simulate most of the widely used microcontroller boards like PIC, Arduino, STM32 and ESP32, etc. Block diagram: power on switch SW5, push or stop switches SW6, navigation switches SW switch 4, door status switch 1, and goes to microcontroller and display the LCD of washing machine status, then buzzer and motor. Components used: Tactile switch. These are the switches which will be on module or only when the switches is pressed. Here the RB3 is used as switch 4, navigation scrolling between options. The RB4 is used as switch 5, powering on washing machine and resume. The RB5 is used as a switch 6, stop and push an ongoing program. The RB0 is used as a switch to indicate the door status of washing machine. CLCD. The CLCD in washing machine used for displaying the current status of washing machine. It is also used to show various options and to navigate through them using switches. It is also showing the time remaining to finish the program and also show the wash mode. Timers. The timer in washing machine is used to keep track of washing timers. In the normal washing mode, the time is split into three washing mode: wash, rinse and spin. The timer of each of spin into the certain interval and the same displayed in CLCD. Buzzer. The buzzer in washing machine is used to keep the track of washing machine cycle. The buzzer alarm activates when the door of the washing machine is opened, which is represented by the clicking the BR0 button. It is also activates off for 3 seconds when washing is completely successful. Fan. The fan in the project is used to represent a working of washing machine. The spin of motor starts when any washing mode is selected and continues till the end of the washing cycle. The motor stops when it detects door is open and start again when the door is closed. That is coding part of my project. Here is main.c file. Here is a header file and source file also. Let's clean and build our code. Here is hex file is generated. And code is built. Then let's upload hex file in PICSIMLAB. Here press switch 5 to open machine. I'll select washing machine is on. There is program heavy denied white. I'll select white. Water level auto low and medium, low, medium and high. Press switch 5 to start and switch 6 to stop. I'll press switch 5 for start. Our motor will be started. And press RB0 for door status. If door will be open, the motor will stop, and the door will close, the motor will start automatically. If not, press switch 5 to continue our program. Here is RB0, the door will open, so our machine is stopped. So firstly I close the door and then press switch 5 to continue. And let's start the motor. Press the button. Our motor will be started. When the timer will be stopped, our machine is washing machine is completely done the work. Wait for end the timer. Remove the cloth. Machine washing is complete. Here is the conclusion of our project. In conclusion, our washing machine simulation using the PIC16F877A microcontroller demonstrates not only the practical application of embedded system in household appliances, but also the versatility of microcontroller-based designs. The ease of programming the microcontroller increases the efficiency and can be very handy to create and deploy advanced machines using microcontrollers. They also play a vital role in the development of technologies. Thank you.